Good morning, students. I am Santan, working as a physics teacher in Target English Medium School. In our past videos, or in our past video, I am already clearly explained about what is calorimetry and what is the calorimeter, and in calorimeter which principle is involved. That is nothing but principle of calorimetry or principle of method of mixers. Generally, by using the principle of method of mixers, how we can find the final temperature of the system when two bodies are in thermal contact with a difference in temperature. That is clearly we discussed that. But in this video, I would like to explain about one very important concept for 4 marks in 10th standard level. Regularly this question is asking to us. What is that one means? How we can find specific heat capacity of a substance. It is nothing but here we are inside the solid by using the calorimetric method, or simply we are called but in the calorimetric process, I would like to explain this concept in the two modes. First one is the how we can find specific heat capacity of a solid by using calorimeter method. This concept is in our textbook, is also there. But another new method is also I am telling, that is the how we can find specific heat capacity of a solid by using electrical method also. So during the examination, so if specially they are mentioned, explain the specific heat capacity of a solid by using calorimeter, at that time only we can write the calorimeter method. Otherwise, find how to find specific heat of a solid experimentally, means up to here they are asking, means so you can write the either calorimeter method or electrical method. So in the previous video I said very clearly, calorimetry is nothing but it is a process. In the process of calorimetry we can easily find so the given substance will be absorbed how much heat energy, or liberated or released how much heat energy. That is very clearly find out. But in the calorimetry method, by using a small device we are using that, with help of that device only we can find the body will be absorbed how much heat energy or liberated how much heat energy. The device name is, I say that clearly, that is a calorimeter. That's why in this video, so I try to explain clearly how we can find specific heat of a given solid by using we can find the specific heat of a solid by using the calorimetry method or in calorimeter method. So this is a rough diagram of calorimeter. Already says that calorimeter is made up of either copper or aluminum, because of it is a good, they are good conductors of heat, and it is called stirrer. So now come to that point. So how we can find specific heat of a solid by using the calorimeter method. So come to this one from the diagram. When you can find or when you can do the any experiment, we must be want some operators or materials. Which materials are required to us? So to find specific heat of a solid in by using calorimeter method means so we want calorimeter, water, thermometer, electronic weighing balance, comma, solid pieces, comma, Regnard steam heater, etc. Listen very carefully. So, which materials are required? Okay. So, to prove this, to find the specific heat of a solid by using calorimeter method means we want a calorimeter along with the stirrer, water, thermometer, electronic weighing balance or physical balance, solid pieces, and Regnard steam heater. These are the materials are required for us to find the specific heat of a solid experimentally by using calorimeter method or calorimeter. So here initially I do one small mistake. I didn't get the L. So Regnard L here. That is only we can correct it. So now what is the procedure that is we discussed? So procedure means we know that in what way we can do the experiment, that is called procedure simply. Now come to that one. So first of all we can take calorimeter along with the stirrer. Listen very carefully. First of all we can take an empty calorimeter along with the stirrer and measure its mass and note it as M1. Listen very carefully, all of you students. Okay. So first of all, we can take an empty calorimeter along with the stirrer and measure its mass with help of an electronic weighing balance or physical balance and note its mass as M1. Now the calorimeter is filled with water up to 3/4 level. So now the calorimeter is filled with water up to 3/4 level and measure its mass and note it as M2. Okay, so M1 is represented the only mass of the empty calorimeter. M2 is represented the mass of the empty calorimeter and water. Both are that one is there. Now next what we can do after this one? Now we can take a thermometer. A thermometer is placed into the water of calorimeter. Okay, and measured initial temperature of the water and calorimeter. That is we are noted as T1 degree Celsius. Listen very carefully here. Okay, T1 degree Celsius is represents the so initial temperature of water and calorimeter. Why water and calorimeter means? So already I said that according to the method of mixture. In the method of mixtures, how many substances are there? 2 substances are there. So now in this one also, calorimeter is made up of the copper and the water is there. When the water will be poured into the calorimeter, then if generally both are not heated. But so due to the lesser specific heat of the calorimeter, it will be quickly absorbed a little bit temperature from the surrounding. But water will be absorbed very slowly. That is we know that. But when the water will be poured into this one, we are considered calorimeter is the one object and water is the another object. That's right. So then what will happen? Heat energy will be flowed from higher to lower. But if two are but we cannot observe in here because of initially both are at the room temperature only. That's why both are at the room temperature means if you place a thermometer, both are at the same temperature means what is the meaning? They are in equilibrium position, thermal equilibrium. That's why the temperature of the calorimeter and temperature of the water is the same. That is nothing but simply T1 degree Celsius. Listen very carefully. First of all, we can take an empty calorimeter along with the stirrer and note that its mass is M1. Next, the calorimeter is filled with water up to 3/4 level and measure its mass and noted as M2. Then now we place a thermometer into the calorimeter and noted its initial temperature is T1 degree Celsius. After that, what we can do here means, okay. So now, which one we are find out here? Specific heat of the solid. That's right. So they are given some solid pieces to us. Most of the cases, okay. So generally, this experiment you can do in the intermediate second year. So generally, during the experiment, most of the cases they give lead pieces to us. Why lead pieces they are given to us means lead pieces specific heat capacity is very less. Okay, that value we know that, okay, 0.093. Okay, so due to that one, due to the lower specific heat capacity, we know that, okay, if a substance has lower specific heat capacity, it absorbs the heat energy very quickly and it will be release the heat energy very quickly or fastly. That's why, okay, so the lead pieces, when you can heat it, they absorb the heat energy very fastly. That's why, so we can avoid the time killing or time consumption during the experiment. Okay, for that purpose, we are taking the which one? Lead pieces. Okay. So now, how much lead pieces they are given to us? That lead pieces, okay. So we can keep into a lightweight plastic cover and we can measure the mass of the lead pieces. That is, we are noted as M3. Listen very carefully. So they given some lead pieces. The lead pieces you can take into the lightweight of a plastic cover and we can measure the mass of the lead pieces by using the electronic weighing balance or physical balance and noted as M3 mass. That one is it. Okay. Now in the other hand, okay, a Regnalt steam heater is there. So it is a rough diagram of Regnalt steam heater. Okay. So in the Regnalt steam heater, what we can do means, okay, like this one is there. Now initially, okay, in the lower way means here one small, okay, spout is there. Through this small spout, okay, we fill the water in the Regnalt steam heater. Okay, so the water chamber, okay, so means the Regnalt steam heater we are mentioned as the two parts. Okay, the two parts are divided by the, okay, a copper strip or copper layer. Okay, so at the lower chamber, which is there, water is there. In the upper chamber, we place the solid pieces. Okay, because if there is no copper strip between the upper chamber and lower chamber, what will happen when the solid pieces will be, okay, poured into the Regnalt steam heater, they mix with the water. That's why, so we find the specific heat of the solid separately. It is not easily possible to us. That's why, do not mix with each other. What will be happen? The chambers are already separated by a copper layer or copper strip, and already you know that copper is a good conductor of heat. That's why lower chamber is water and upper chamber is in the upper chamber. We pour or keep the which one? Solid pieces. And okay, it is closed with a rubber card. Now come to that one. So this Regnalt steam heater, we are gradually heated by placing over a Bunsen burner. Okay. So and if you can heat it up to some time, and after that we place a thermometer by removing this one and measure the solid pieces temperature. Here, okay, by using the Regnalt steam heater, the solid pieces were heated, okay, up to 80 degrees Celsius. Not only exactly 80 to 90 degrees Celsius we can heat it. Okay, when the temperature of the solid pieces is reaches to lies between 80 degrees Celsius to 90 degrees Celsius, then immediately remove the Regnant steam heater from the Bunsen burner, and so through this spout, we pour the lead pieces into the calorimeter. Listen very carefully. Okay, when the solid pieces are temperature is reaches to the lies between 80 degrees Celsius to 90 degrees Celsius, at that time what we can do? Remove the Regnant steam heater from the flame, and immediately the solid pieces will be transferred into the calorimeter. Transferred into the calorimeter. Okay, when it is transferred into the calorimeter and stir very well with the help of the stirrer, and already I said that this calorimeter is already enclosed in a wooden chamber. In our past video I will be clearly explained. Okay, so why it will be placed in the wooden chamber means we can avoid the loss of heat energy by the three modes: conduction, convection and radiation. Okay, for that purpose it will be kept into a wooden chamber. Okay, that's one. So now this wooden chamber will be have one opening hole at the upper end. This hole is closed with a wooden lid, but the wooden lid will be having one narrow hole. I says that through that narrow hole, what we can keep? We keep a thermometer into the calorimeter. For what purpose we place the thermometer in it? To measuring the final temperature. That's why when we place the thermometer here, we are observing that the temperature is gradually rises. The temperature of the water is gradually rises. Why the temperature of the water is gradually rises means hot solid pieces already we can keep into the which one? Calorimeter. That's why in the calorimeter what is present? Water is present. Now here we are observing that solid pieces acts as the hot body and water acts as the cold body. That's why water is absorb the heat energy from the solid pieces. At the same time, solid pieces loses the heat energy. That's why the water temperature is gradually increases. After reaches to particular temperature in the thermometer, up to few seconds there is no change in the temperature of the reading. So when there is no change in the temperature of the reading up to few seconds, that is represented. Okay, so the entire system in the calorimeter is nothing but water, copper vessel and solid pieces are in thermal equilibrium is nothing but common temperature. That temperature we are noted as T3 degrees Celsius. But what about the T2? Okay, so T2 degrees Celsius is represented which one? Temperature of the hot solid pieces. What is the temperature? Lies between 80 to 90 degrees Celsius. Okay, this is the way of the method we can follow for finding the specific heat of solid by using the calorimeter. Okay, so once again listen, in what way? Okay, so we find means I will do one more and explain what is the procedure involved in this process. First of all, we can take an empty calorimeter along with the stirrer and measure its mass with the help of the weighing balance and noted as m1 grams. Now the calorimeter is filled with water up to 3/4 level and measure its mass and noted as m2 grams. Now we can take a thermometer. The thermometer is placed into the calorimeter. It is already contained with water and noted its initial temperature as T1 degree Celsius. Further, so which mass of the solid pieces they are given, or they give some solid pieces. The given solid pieces we can weigh and noted as M3. M3 is represented mass of the solid pieces only. Now this mass, the solid pieces we can take it into the Regnant steam heater and the steam heater is placed over the Bunsen burner and gradually heating. Okay, so the solid pieces were heated up to, okay, lies between 80 degrees Celsius to 90 degrees Celsius. That temperature we are noted as T2 degrees Celsius. T2 degrees Celsius is represented the temperature of the hot solid pieces or hot lead pieces. That is the meaning of that one. And now after the temperature of the solid pieces is reaches like this temperature, immediately we can remove the Regnant steam heater over from the flame and they are immediately transferred into the calorimeter and still very well by placing in the wooden jacket and close the lid finally. And already a thermometer is placed in the calorimeter. That's why in the thermometer we are observing that the temperature is gradually increases. When the temperature reaches to one particular position on the thermometer, we are observing that up to few seconds, okay, there is no change or rise that temperature in the thermometer. That is what is the meaning of that one means at this temperature, solid pieces, water and copper vessel, these three are in thermal equilibrium. Is nothing but they have the common temperature. That common temperature we are noted as T3 degrees Celsius. So after the procedure, okay, how we can do the calculation? So what is the importance of the calculations means? With help of these calculations, okay, you can easily find specific heat of a solid with help of a formula. To find that formula or to derive that formula, these calculations are very important to us. Okay. So now come to that one. Mass of an empty calorimeter, that is equals to m1 grams. Mass of an empty calorimeter and mass of the water, which, okay, how much amount of water or how much quantity of water we can pour into it, that is one. Total is m2 grams. Means m2 is nothing but not only the, okay, mass of the empty calorimeter, okay, it is along with the mass of the water also. Means M2 is represented mass of the empty calorimeter and mass of the water combining. That is the meaning of that. Next, initial temperature of calorimeter along with water. Okay, so that is T1 degrees Celsius. Mass of given solid pieces, that is M3 grams. Temperature of hot solid pieces, that is equals to T2 grams, and final temperature of the mixture is T3 grams. Already these all the calculations I will clearly explain in the procedure. So here for finding the specific heat of a solid, okay, by using calorimeter means, okay, so which principle is involved? That is, you know that very clearly. Principle of calorimetry or principle of method of mixtures, because of, okay, so in this process we know that, okay, totally how many substances we are taking, that copper vessel, water and hot solid pieces. That's why we are says that, okay, means in this concept one hot body is there, one cold body is there, and also I clearly explain to you, okay. So what is the principle of method of mixtures or principle of calorimetry? If any two bodies with a difference in temperature, okay, if they are brought in thermal contact, heat energy will be transferred from a body at higher temperature to a body at lower temperature until both are attain thermal equilibrium, is nothing but common temperature. But finally, so what is the main principle? I said that, okay, so heat energy lost by the hot body is always equals to heat energy gained or taken by the cold body. Here in our calorimeter concept, calorimeter and water we are considered as a one body, means one system, and hot solid pieces we are considered as another body or another system. That's why, so calorimeter, water, initially both are acts as the cold bodies, and okay, solid pieces are acts as the hot body. That's why when these two are not in the same temperature during the mixing, okay, solid pieces are hot, calorimeter, copper vessel, and what is the cold. That's why when you can add it into this one, what will be happening? Okay, so the solid pieces are loses the heat energy or lost the heat energy. That heat energy will be taken by the copper vessel and water. Okay, so that is that's why we are using the which concept here? Principle of calorimetry or principle of method of mixtures. So that's so simple you can write that. According to principle of method of mixtures. So what is the principle? Heat energy lost by a hot body. Here, okay, heat energy lost by which one? Solid pieces. That's right. Heat energy lost by solid pieces is equals to heat energy gained or gained by calorimeter and water. So listen, okay, according to principle of method of mixtures. Okay, what is the principle of method of mixture or principle of calorimetry? Means heat energy lost by hot body. Here, according to our concept, which is the hot body? Solid pieces. That's right. In the place of hot body or instead of the hot body, we can write the solid pieces is equals to heat energy gained by calorimeter and water. Okay, here which are acts as the cold bodies? Solid pieces is acts as the hot body, and calorimeter and water, these two are acts as the cold bodies. That's why in the place of cold body we can write the calorimeter and water. So according to the principle of method of mixtures, heat energy lost by solid pieces we are considered as a Q1, that is equals to heat energy gained by the cold body, that is we are considered as a Q2. It means nothing but calorimeter and water. Here listen, Q1 is represented the heat energy lost by the solid pieces, because of Q is the simple, it is represented the amount of heat energy. Next, Q2 is represented the heat energy taken by the calorimeter and water in this concept. Okay, and already in the specific heat concept I am clearly explained to you. Okay, what is the formula to find the Q value? Q is equals to ms delta T. That is that very clear. Okay, so I will write here Q is equals to ms delta T. So now come to that one here. Okay, so in the Q1 is belonging to the hot solid pieces, that is that's why based on that one you can come. M means what is nothing but, so Q1 is represented the solid pieces, that's why these all the components means mass, specific heat, change in temperature, we are considered about the solid pieces only, that is remember, that's why. So now come to that one. M is nothing but what is that one? Mass belonging to which one? Solid. That's why mass of solid pieces. What is the mass of solid pieces? M3. Then you can write here M3. In certain textbooks, okay, the mass of given solid they are considered as a M also. That is our wish only, not only M3. Anyone you are considered that here. So in the place of M, what you can write? Mass of the solid pieces. Next, S is represented the specific heat capacity. Which specific heat capacity? Q1 represented which one? Solid pieces. Okay, which solid pieces we are taken here? Lead pieces. Okay, not only lead, whatever that may be. That's why we can write that S of S. Okay, means M3 is represented the mass of the hot solid pieces. Sorry, mass of the solid pieces. S of S is represented the specific heat of the solid pieces. Okay, so the capital S is the specific heat represented, small s is the represented the solid pieces. That's why specific heat of solid. Next, what is there? Delta T. Delta is nothing but change. T is the temperature. Change in temperature. I say that according, okay, during the method of mixtures. Okay, so hot body temperature is decreases and cold body temperature is increases. When you can comparing, okay, so hot body temperature is always higher than the final temperature and cold body temperature is always lower than the final temperature in the mixtures. That's why, so about the solid pieces you can write that T2 minus T3, that is Z equals to, listen, okay, so T2 is the solid pieces. What is that one? Hot solid pieces temperature T2 and T3 is represented the final temperature. That's why hot solid pieces temperature is always more than the final temperature. That is already explained in the past class videos. That's why T2 minus T3. Next one, Q2. In the Q2 is represented which one? Heat energy gained by the cold body. Here, how many cold bodies are there? For us, two bodies are there. One is the calorimeter. Okay, calorimeter is nothing but copper vessel along with the stirrer. That is the meaning of calorimeter. And which one is there? Water is also there. Okay, so that's why here. Okay, so now what we can write in this one? First thing, okay, heat. Okay, so from this concept, first we can say that, okay, heat energy taken or heat energy gained by the calorimeter. First we are considered that heat energy gained by the calorimeter means first we are considered only calorimeter but not consider the water. That's why, so calorimeter mass is, what is that one? Okay, we know that mass of an empty calorimeter. What is the value? M1. That's right, M1 in the place of M. Next, S means specific heat of the which one? Calorimeter. That's why C we can put. Next one, delta T, change in temperature. Calorimeter is acts as a cold body. So in the method of mixtures we know that. Okay, so cold body temperature is always lesser than the final temperature. That's why we can write T3 minus T1. That's it. Okay. Next, plus. For this one, continuation, plus. Why I will put the plus here? In the cold body places, not only the calorimeter, along with the calorimeter, water is also there. That's why water is also absorb the heat energy or not. Okay, so we know that. Why we are specially consider means we know that calorimeter is made up of the copper vessel. Okay, copper vessel specific heat is very less, but water specific heat is very high. That's why when the solid pieces we can take it into the calorimeter already contained in the water. Okay, so the copper will be absorbed more heat energy than the water due to lesser specific heat. That's why we are separately consider the heat energy absorbed by the copper vessel and water because of their specific heat capacity is not same. That is the reason. That's why we are considered separately. Now come to this one. Okay, this is belonging to about which one? Calorimeter. Next one, how much heat energy gained by the water. That's why for the water, M is represented the mass of the water only. But here, how we can find mass of the water only? But okay, in the calculation part, we are observing that M2 is represented water plus empty calorimeter mass. But we want only mass of the which one? Okay, water means what we can do here. So come to this one. Okay. Here I will tell that mass of an empty calorimeter and water. In the place of and, I will put for understanding of plus. Plus means combined. Okay. It is what is that one? Mass of water. We are right. Okay. So mass of an empty calorimeter. What is the value? M1. That's why in the place of this we can write as M1 plus what is the here? Mass of water, that is equals to M2 grams. But we want which one? Only how much mass we are taken how much mass we are poured or taken into the calorimeter. That's why this M1 transferred to the right hand side, then its value becomes to the negative. Then so mass of water only is equals to M2. M1 will become to this side minus M1 grams. That's why the mass of the water only, what is the formula? This one, M2 minus M1. That's why in the place of M, what we can write? M2 minus M1 here. M2 minus M1. Next, S means specific heat. Okay, here which one? Water. That's why SW. W is nothing but specific heat of water. Next, delta T means change in temperature. T3 minus T1 because of it is a cold body. So listen very carefully. Okay. So Q1 is represented the heat energy lost by the hot solid body or hot solid pieces. Q2 is nothing but heat energy taken or gained by the calorimeter and water separately. Why we are considered the two separately? I said very clearly. Okay, copper specific heat and okay, water specific heat is different. That's why okay, copper will be absorb heat energy very fastly when compared to the water due to the lesser specific heat. That's why the absorbing final temperature is constant, but absorbing heat energy is different due to the okay specific heat capacity. That's why so heat energy okay lost by the hot body for that one M3 S of S T2 minus T1, and in the place of Q2 heat energy gained by calorimeter plus heat energy gained by the water. That is the meaning of that one. That's why heat energy, how much heat energy gained? M1 mass of the calorimeter only. S of C specific heat of the calorimeter, change in temperature T3 minus T1. Next okay, how much heat energy gained by water only? Mass of the water M2 minus M1, specific heat of the water S of W and T3 minus T1. Now after that one, okay, so which value we can find? Specific heat of the solid. That's why here S of S is represented the specific heat of solid. Due to that M3 of T2 minus T1, these values you can transfer into the right hand side from the left hand side. That's why S of S is equal. So here T2 minus T3. Okay, now come to that one here. So you find which value? Specific heat of the solid by using this method. That's right. So we place okay, we keep the value here only in the left hand side. The remaining values you can transfer into the right hand side. At the same way, in the right hand side, okay, which is the common thing means okay, T3 minus T1 is the common factor. Okay, so at a time we can do here M1 SC plus M2 minus M1 of SW into T3 minus T1. So listen, okay, T3 minus T1 is the common factor in the right hand side. That's right. So M1 SC plus M2 minus M1 of SW into T3 minus T1 upon okay. So here from the left hand side, okay, sorry, in the left hand side M3 and T2 minus T3 we transfer to which side? Right hand side. That's right. So M3 okay of T2 minus T3. Okay, so this is the formula to find the specific heat of the solid experimentally. So now listen very carefully here. M1 is nothing but mass of the empty calorimeter. Already we know that. S of C means specific heat of the calorimeter. So calorimeter is mainly made up of the copper. So its specific heat is we know that 0.03. Okay, sorry, 0.093. Okay, next M2 minus M1 is nothing but mass of the water only. S of W, specific heat of the water, that is 1 calorie per gram degree Celsius. T3 is the final temperature we find in the experiment. T1 is the initial temperature of the water under calorimetry. Next, M3 is mass of the solid pieces only. T2 is the hot solid piece temperature, and T3 is the final temperature. Already we know that each and every value in the formula. If we can substitute that all values, finally we can get which value? S of S means specific heat of the solid. So now we discuss another one more method. How? Okay, that is the electrical method or electric method. In the electrical method, how we can find specific heat of a solid? That is, we discuss that. But listen very carefully. This method is not suitable for everything. Means okay, solids, liquids, or any other thing. This method is only suitable to find the specific heat of good conductor of solid pieces only. So we know that lead has the lower specific heat. That's why it is acts as a good conductor of heat, like the copper. Due to that reason, okay. So this method is also applicable to write during the examinations. Okay. So okay, generally I say that clearly. Most of the cases in the intermediate second year stage, we conduct the experiment about the specific heat concept. In that one only, they give the lead pieces only to us. That's why electrical method is also one of the suitable method to find the specific heat of the lead pieces. Now, if according to this method, how we can find, that is we discuss in this time. But in this method also, if you can find or if you can do any experiment, whatever the method you can follow, we must want some materials or operators, and which materials or operators are required to us to find the specific heat of a solid in this method. Means first of all, we want a large beaker. Next one, solid pieces. Next one, now power of electric immersion heater. Thermometer and power supply is nothing but AC, alternate current. So which materials are required to us? Okay, so to prove to find the specific heat of solid by using electrical method, means a large beaker, solid pieces, known power of electric immersion heater, thermometer, power supply, and along with this one, weighing balance is necessary. Weighing balance, etc. So these are the materials or operators are required to us in this method. So now it is the rough diagram of electrical method for finding the specific heat capacity of the solid pieces. Here the circles are represented solid pieces. So it is represented the electric immersion heater. Electric immersion heater. It is represented the AC supply is nothing but alternate current, that is we are used in our home. It is a switch or plug key. These are the connecting wires. That is a brief idea of the circuit in this electrical method. So in what way we can find a specific heat capacity? That is we discussed under the concept of procedure. So what way we can follow? Means First of all, we can take a large beaker. Solid here, it is closed, okay, with a wooden lid. So come to that one. First of all, we can take, okay, a large empty large beaker, and in this beaker, okay, in that large beaker we have taken the, okay, now mass of solid pieces. Means how we are understanding means are simple as is that. First of all, we can take, okay, some quantity of solid pieces. That quantity of the solid pieces by keeping on the electronic weighing balance or in physical balance and measure its mass and noted as M. Listen very carefully. So M is represented the mass of, okay, solid pieces. Simple I will write here. Okay. So mass of solid pieces, that is valued as a m grams simply. After that, this m grams of the solid pieces we take it into a empty beaker, and after that one, okay, now we can take a thermometer. The thermometer is placed into the solid pieces and measure its initial temperature. That is the simply initial temperature of solid pieces. That is, okay, SP means solid pieces, that is equals to T1 degree Celsius. After that, now we can take a known power of electric immersion heater. Generally, in our homes we are using for the purpose of heating of the water. Okay, some of the persons are using the geysers. In the geyser also heater is there, but okay, manually also we are using that. Okay, that is simply we are called as electric immersion heater. Immersion means you can keep into the water. That is meaning of that. So generally, when you can buy any immersion heater or any geyser, okay, already they are graduated the, okay, power reading on it. So generally, okay, from which power onwards they are available means 1000 watts, 1000 watts is nothing but 1 kilowatt, 1.5 kilowatt, 2000 watts. This capacity of the electric immersion heater is available in the market. So that's why now power is nothing but any one of the electric heater we can take it. For example, 1 kilowatt or 1000 watt capacity of the power of electric heater we can take in that. Okay, so that heater, okay, completely we kept between the solid pieces, and it is connected to the AC circuit, okay, through a plug key. So now when the, okay, key is closed in the circuit here, when the key is closed in the circuit, what will be happen is nothing but the switch will be on. What will be happen? The power will be supplied to the immersion heater. Okay, that's why. So you know that in the immersion heater, what will be happen? Electrical energy is converted into the heat energy by the high resistance. Okay, so due to that one, the releasing of heat energy from the heater, it is absorbed by the which one? Solid pieces. Because of here, okay, in this concept, okay, so which is the hot body? Heater is the hot body, and solid pieces are acts as the cold body. That's why. So the heat energy is produced by the heater. That heat energy will be taken by the solid pieces. Now we can heat the, okay, so means we can allow the current up to certain time, and later we place a thermometer in it and okay, measure the temperature. But generally in this method, in the regular time of interval, we can, okay, measure the temperature of the solid pieces. If the solid pieces temperature is reaches to the, okay, maybe 80 degrees Celsius to 90 degrees Celsius. When the solid pieces temperature is reaches to rise between 80 degrees Celsius to 90 degrees Celsius at any one, at any value, so you can stop the power supply. Okay, and come to that one. Okay, so what is the third point? Okay, so final temperature of solid pieces, that is varies as a 20 degrees Celsius. Here T1 is the before absorbed heat energy, T2 is the after absorbed heat energy. That's why T2 is represented the higher temperature, T1 is represented the lower temperature. Once again listen. First of all, we can take the given quantity of the solid pieces and measure its mass by using electronic weighing balance or physical balance and noted as m1 grams. So m is represented the mass of solid pieces only. Next one. Now this solid pieces we can take it into a large container or beaker. After that, now we can take a thermometer. The thermometer mercury bulb we place into the solid pieces and measure its temperature, that is called initial temperature of the solid pieces, and noted as T1 degree Celsius. Next, now we can take the noun power of electric immersion heater. This noun power of electric immersion heater will be placed between the solid pieces inside the beaker or container and connected to the AC circuit. When the switch is on, in the circuit, the power will be the current will be transferred to this one. Then what will be happen? The electrical energy is converted into the heat energy in the heater, and the releasing of heat energy is absorbed by the solid pieces. That's why in the electrical method, which is the hot body, heater is the hot body, which is the cold body, solid pieces is the cold body. That's why heat energy is lost by which one? Heater, and heat energy gained by which one? Solid pieces. Then finally, so the solid pieces were means we allow the current or we supply the current up to how much time, means when the solid pieces temperature is reaches lies between 80 to 90, we stop to supply the electricity or current to the immersion heater. That's why the final temperature of solid pieces is what is that one? T2 degree Celsius. So according to principle of method of mixtures. So why we are considering the mixtures means in the method of mixtures we must be want how many materials or substances too. One is the hot, another one is the cold. Here is also immersion heater is hot body and solid pieces we can say as the cold body. That is, you know that. That's why according to principle of method of mixtures, we know that heat energy lost by heater or heat energy given simply given by heater, that is Z equals to heat energy gained or taken by solid pieces. So listen here, heat energy given by the heater is equals to heat energy gained or taken by the solid pieces. So now here, heat energy given by heater we are considered as a Q1. Heat energy gained or taken by solid pieces we are considered as a Q2. And already we know the formula. Q is equals to ms delta T. M is the mass, S is the specific heat, delta T is the change or rise in temperature. That's why we can follow that one here. Q1 is represented. The heater will be given. How much heat energy to the which one? Solid pieces. But how we can find here? Means that's why. Already in the past video under the specific heat concept, I will tell that Joule's law for heat capacity. Joule's law, in the concept of Joule's law for heat capacity, I says that when work is done against the friction, heat energy is generated. That's why the amount of heat energy generated is always directly proportional to the work done against the friction. Okay, that's why. So work done is nothing but what I have mentioned that here, heat energy, because of how much work is done, that is always equal to the producing of heat energy. So that so in the ninth standard level we know that power concept is there. So in the power concept, P is equals to, we know that, W by T. W by T. So W is nothing but what is that one? Work done. T is the time. Okay. But in the place of W, what you can take in that? Q. Listen very carefully. In the place of W, what you can take in Q? Why you can take in Q here? That's why it says that Joule's law for the heat capacity in that concept. Okay. So the work is done against the friction. Always what is produced, heat energy will be produced. That's why. So how much work is done against the friction, the same amount of heat energy will be also produced. That's why instead of the W we can take it as a Q, and here T is the time. So now come to that one. So from this one, what we can write? Q is equals to. So here we can take in the capital T, either small t or capital T. T is represented the time. Q is nothing but this T transferred to the left hand side. We can write as a PT. P is the power of immersion heater, that is either 1000 watts or 1.5 kilowatt or 2000 watts or 2 kilowatts, like this one. T is the how much time you supply the current to the which one immersion heater. T is that is nothing but. That's why in the place of Q1, Q1 is represented heat energy given by the heater. That's why in the place of Q1 we can write what is that one? PT. PT, that is equals to. So Q2 is nothing but heat energy gained by the solid pieces. So what is the mass of the solid pieces? I said that M. So S is nothing but specific heat capacity. So specific heat capacity of which one? Solid pieces, means S of S. Delta T is nothing but change in temperature. That's why what is the change in temperature? T2 minus T1. T2 is the final, T1 is the initial. But here, which value we can find the specific heat of the solid? That's right. So in the left hand side, which terms are there? P is the power of the immersion heater. T is the time which is supplied the current to the heater. M is the mass of the solid. S of S is the specific heat of the solid. T2 minus T1 is the change in temperature. That's right. So if according to this concept we find the S of S value, means specific heat of the solid. That's right. So mass and T2 minus T1, these two values were transferred into the left hand side. That's why what we can write here, S of S is equals to PT, means PT is there, that is PT upon these two values transferred to this side, it becomes to the M into T2 minus T1. So this right side term value we can bring to the left hand side. It will become under to the denominator. That is, that's why this is the main formula to find the specific heat capacity of the solid pieces according to which method? Electrical method. Once again listen very carefully. So first of all we can take some given solid pieces and measure its mass by using the weighing balance and note it as grams. Next, now we can take a thermometer. The thermometer is placed in the solid pieces and noted its initial temperature, that is the T1 degree Celsius. Now we can take a known power of electric immersion heater. This immersion heater we completely placed inside the solid, between the solid pieces, and connected to the AC supply. When the switch is on, then what will be happen? The current is or electricity is supplied to the heater. When the electricity is supplied to the heater, in the heater what will be happen? The electrical energy is converted into the heat energy because of due to higher resistance. Okay, that's why. So here heater is acts as the hot body because of it produces the heat energy. That producing heat energy is taken by which one? Solid pieces surrounded by it. Okay, so that's why in this concept we are using the method of mixture. Okay, but here the solid pieces, okay, means are nothing but we are allow the current up to which time means the solid pieces temperature is reaches to the lies between 80 to 90 degrees Celsius. At that time we switch off or we stop the supplying of current in the circuit. Then according to method of mixtures we know that heat energy given by heater because of here heater is acts as the hot body and heat energy gained are taken by solid pieces. Heat energy given by the heater that is as a Q1 means Q1 heat energy given to the solid pieces. That heat energy will be taken by which one? Solid pieces. That is nothing but Q2. But here, okay, how we can find heat energy given by the heater means we are not using the regular formula. We can use the another formula based on the power. That's why we know that power is nothing but work done by time. That's why work according to the Joule's concept, the work is done against the friction, heat is generated. That means how much work is done against the friction, that much of heat energy will be produced or generated. That's why instead of the W means work done, we can use the which one? Heat energy produced by it during the work against the friction. That's why power is equals to heat energy produced by what is that for time. Then from this one Q equals we can write the PT. Q is the heat energy given by the heater, that is nothing but power of the heater into supplied time. Then so in the place of Q1 we can write the PT and in the place of Q2 what we can write by using regular formula. M means mass of the solid pieces, S means specific heat of the solid pieces, delta T final minus initial temperature. Then finally S of S equals to PT by M into T2 minus T1. This is the formula to find specific heat of the solid according to electrical method.